Beauty is in the eye of the beholder, or so we're told. But could there be hidden patterns that dictate what we find attractive in our buildings, in art and in nature? For centuries, artists have found that there's one particular proportion that appears to please us more than any other. It's become known as phi.
The idea behind phi goes back to Euclid. He called it extreme and mean ratio. It's actually a very simple idea. Take a line and divide it into two pieces in such a way that the ratio of the whole line to the big piece is equal to the ratio of the big piece to the small piece. That's it.
This ratio turns out to be approximately 1 to 1.618. It may not sound auspicious, but its proportions are so pleasing that it's been known since the Renaissance as the golden ratio, and no one appreciated its significance more than Leonardo da Vinci.
Some people have seen the proportions in the Mona Lisa as examples of the golden ratio and of this interest in geometry. I think this is controversial, but it's certainly interesting that the mathematical elegance of phi and a definite visual elegance of the corresponding proportion do seem to go hand in hand.
And it's not just artists who've exploited its mysterious appeal. It can also be detected in some of the world's greatest architecture, from ancient Egypt to classical Greece, to Le Corbusier's modernist designs, to modern-day Cornwall. And it has a surprising connection to a seemingly unrelated area of mathematics.
800 years ago, Leonardo Fibonacci, who was an Italian mathematician, asked a question about rabbits. Suppose you have a pair of rabbits, and it takes them 1 year to mature, and then they have a pair of baby rabbits, and they keep on having baby rabbits every year, and the baby rabbits take a year to mature, and then they have babies as well. After, say, 10 years, how many rabbits have you got?
What we notice is that each new number is the sum of the previous two. This became known as the Fibonacci sequence.
If you take two consecutive numbers and divide the big one by the little one, so 8 over 5 is 1.6, well, that's already quite close to phi. 13 over 8 is even closer. 21 over 13 closer still. And the further up the sequence you go, this ratio of the two numbers gets closer and closer, as close as you like, to phi.
So there appears to be a profound link between phi and the Fibonacci sequence. And the breeding patterns of rabbits isn't the only natural phenomenon that's described by the Fibonacci sequence.
If you look at the seeds in the head of a sunflower, you find that they're arranged in spirals. And you get one family of spirals which curls in one direction, and another family of spirals that you can see curling in the other direction. And if you count the number of spirals one way, you get a Fibonacci number. And if you count the number of spirals the other way, you get the next Fibonacci number. This is a pattern that occurs throughout the plant kingdom. This is not a fluke. This happens because the Fibonacci numbers give you the most efficient way to pack the seeds together. And nature has discovered this and is making use of it.
Mathematicians are still investigating the link between beauty in art and the practical functions of nature found in the connection between the Fibonacci sequence and the golden ratio.
What we're all looking for, mathematicians, artists alike, is to reflect the harmony of the world in which we live.
To learn more about numbers, go to the Open University's website at open2.net.